guys are watching these more than once. I don't know. Actually, some of you aren't watching at all.
We're great students.
Because you don't need it more than once. Just see it once, you're good.
Because you watch it 10 times to use your viewer time. So
Thanks.
the algorithm can
That's
pick
cool.
it up.
And still no thumbs up, huh?
I can only give one design, sorry.
All right. So, I don't know if you saw the emails.
Hopefully my BIOS.
What's going on?
My computer's being loud because I'm updating my BIOS.
Oh.
Perfect time to do
Pretty
it.
brave thing to do, yeah.
Yeah.
So skill check next Wednesday.
Ooh, alright.
Yeah, I sent out an email. Good student.
I got scared of it, I couldn't read the rest of it.
Oh, okay, yeah. I'm intimidating.
Transfer them to a BIOS.
So then Monday today we're gonna do vector valued functions. On Monday, we're gonna do we're gonna start the calculus of multivariable stuff on,
Quadruple integrals.
what's that?
Quadruple integrals.
No, actually in a different way. We're gonna do integrals of vector functions, which are what we're gonna talk about today. We will get to multiple integrals, but not yet.
Isn't integrals of multiple vectors just integrals of the components of the vectors?
Pretty much,
So
yeah,
it's
it's
still-
not gonna take long.
Still electromagnetic, so
No.
technically.
Okay.
Just admit it.
Yeah, no, I'm not gonna admit it, because it's not true. It's semantics, it's more than semantics. All right, so vector value functions. I mean, in the end, what will be more important is taking derivatives of these things, so like doing integration on it's gonna be kinda like lame.
Yeah.
For the most part. But doing derivatives here are gonna be awesome because we're gonna have some weird curve in space, particle moving through space and be able to compute its velocity, which is a vector once we're moving in space, and its acceleration vector, and then maybe some weirder stuff that's associated with all that. But vector value functions, we kind of already seen one of these. And I will be mindful of the time. I know I took 5 minutes extra of your time last class, but what's that the equation of? It's the direction vector. There's a direction vector. There's a direction vector.
Is it a line?
It's a line. It's a line through this
plane.
point.
A plane.
It's not a plane. It's a line through a point. Are you gonna be trouble today? It seems like it. It's a line in space or in the plane. In the plane. It could be in the plane, but it's not a plane. Here we go with that conversation again. So it's either a line in the plane going through point P naught with direction vector V, or it is a 3D thing. And luckily, all situations are accounted for. So there's P naught, kind of rising up out of the plane, and then that has some direction vector. And that direction vector itself also has, let's try to make it look a little 3D-esque. I don't know if that's really doing it there. It's just not put 3D stuff on that. So it's the equation of all the points that are parallel to that vector through that point, and as t varies, and I'm going to make some changes about this today. Here we're just assuming t is a number between minus infinity and infinity, so it's any real number. And as t changes, we move along this line to different points. When t equals 0, we're at the point we know, P naught. As t goes negative, it moves in the opposite direction of the vector. As t goes positive, it moves in the direction of the vector. And that's true here, that's true here. But we're gonna get a lot fancier today. Oh, is that telling something resonate there?
No, it was just, I didn't see that negative infinity does
Oh.
not look like anything. In the,
Really?
It looks like an infinity now.
Yeah, it does look weird. You're right. You're good now. Let me fix it. Better-ish? Okay, cool. So we're gonna start looking at other functions that take a parameter t and spit out a vector depending on the value of t. So that's this whole topic today. We're probably not going to start doing the calculus until Monday, which I think will be fine. So let's look at some examples. I think I just wanted to kind of warm up with some examples. And then we'll start off in the plane, because this is actually a very fundamental one that I want you to know very well. It's really important to actually know this particular vector valued function. So it spits out a cosine of t and a sine of t, and I want to show you some ways to get intuition about these things. And I also want you to remember what sine and cosine look like. So I'm going to put a cosine graph right here. I'm going to put a sine graph right here, and they're going to depend on t. And we're going to do just one period's worth. So I've got 2 pi radians there. I want them lined up really well. Then halfway across is pi, halfway across is pi. There's pi over 2, that's 90 degrees, 180, 270, 3 pi over 2. That's pi over 2, that's 3 pi over 2. All right, that barely looks like a pi. So magnitude is 1. So we go 1 to minus 1. Here I go 1 to minus 1. And when we sketch these out, I'm just going to draw a little box, because that helped the way that one looks subpar. It doesn't look like the same one, so that's a little better. Across, up, cosine starts at its highest point, ends at its highest point, hits lowest point halfway through, and comes on these quarter marks, just that way. And it's a beautiful curve. Yeah. Subpar again. I'm going to do the same thing down here for sine. Sine starts at 0, hits 0 halfway through, goes back to 0 at the end of the period, hits its peak at pi over 2, hits its trough at 3 pi over 2, and then looks like this. You should be able to reproduce those graphs. That's just a good thing to do. Just if you're a science person, to know these graphs and be able to reproduce them beautifully and accurately when called upon to do so, or when you just need it. It's good for your brain to have these in your head. So let's think about what might be happening here. So for example, r at 0, at 0, that's when t equals 0, and we see that cosine is 1 and sine is 0. So the vector that comes out is 1, 0. I'm going to make a picture down here as well. So here is 1, 1, 0. Now, what we're mostly focused on here, just kind of like over here, when we have the line going through here, and we have the vector equation, r of t is a vector whose tip is on the line. So there's r of 0 right there. R of 1 is a little further out. It's this vector, but it's the tip of the vector that we're kind of focused on. R minus 1's back here somewhere. Is this making sense? Just let me know if this is making sense, or if there's any questions. Yeah, cool. Okay, so we're going to do the same thing here, and I'm only focused on the tip. I drew the vector, but it's just this tip that I'm focused on. Now, as t, so the t is hidden here. This is kind of like the x and y. This is the x, this is the y. I'm not seeing t here until I see motion. T is exposed over there though. So notice that as we move t from 0 to pi over 2, which would be like this. So this is t equals 0. This is t equals pi over 2. It's kind of like polar coordinates. T equals pi. And t equals 3 pi over 2. As we move from 0 to 2 pi, and think of that as a rotation, the cosine value goes from 1 to 0. So that's the x coordinate. So as t's over here, I got a little t knob, and as I turn t from 0 to 90 degrees, the x coordinate shrinks to 0. The x coordinate shrinks to 0. Meanwhile, the y-coordinate grows to 1 as t moves from 0 to 2 pi. The y-coordinate's growing, so watch this. So x is moving to the left, it's shrinking. Y is moving up. And I'll prove to you why this is true, but what happens is we see a circular motion to 1. And I'll convince you of that. So we have a circular motion. This is 1, 0. This is 0, 1. And that is that's for pi over 2, when t is pi over 2. And we want to kind of like think of these as particles, so let's add a direction. Otherwise, if I showed you just this arc here, you had no idea which direction I moved from to. Questions on that? Let me show you why I know that it's a circle. So if I take the x-coordinate squared plus the y-coordinate squared, I get cosine squared plus sine squared, and what is that? 1. That says, and this is the length of that vector. This is the length of r of t, no matter what t is. X-coordinate squared plus y-coordinate squared. And that's a circle. Oh, and this should say squared, sorry, right here. So I know that the length of any vector, r of t, with that definition, is going to be on the unit circle. So now see if you can see how this happens. Look at the graphs, see if you understand why this is our next move as t moves from 0 to pi. So in this little window right here, see if you can kind of compare these motions of the graph to the motion that happens here. That's a really flat looking circle. Somewhat upsetting. And if you're not sure what I'm saying that as t moves from 90 degrees to 180, the x-coordinate goes from 1 to -1. So as we go from 90 to 180, the x-coordinate goes from 0 to 1. Right? This is the x-coordinate right here. This is the y-coordinate, the height that we're doing. So you see the x move from 0 to -1. And then you're going to see x go from -1 to 0, and then from 0 to 1. Simultaneously, y is doing this stuff down here. When you trace it all out, and I'm not going to keep belaboring the point, because I feel like it could get a little vegetative. You hear me doing that. And let's make this look like a prettier circle. No, I don't know if that did it. It's a less flat circle. Let's label a couple key values. This point right here, what's the t value right there? It's 180, and we're at the point -1, 0. And even if none of this, if you're like, I don't know what the fuck he's talking about, I don't know trig functions, this isn't making sense, you've got a formula. Plug the values for t in, get the numbers out with your calculator. Worst comes to worst. Also, we're going to look at an app today, and I had sent out an email. I don't know if Daniel read all the way through this one.
You might have skipped that part.
You might have skipped that part, but I said bring your laptop. And if you actually just go to desmos.com and type /3D, you get to the 3D grapher right away. I've finally made that association now. I was always like, have to Google Desmos 3D. It goes there. We're going to look at that later. So this is what I want you to understand. That this cosine sine vector function is a unit circle. So let's play with this and practice understanding this a little bit more. So that means if I gave you then another function, r of t, that looked like this, and I want you to just, don't say it out loud, but I'd like you to think about what's happening. What's the picture? Take a minute, think it through. Without using a calculator or anything like that. Oh, you're good. It's good to have you.
Seems like a pretty good place to hang out over here.
Yeah, we're on big house.
Yeah, see, it seems like you're both fine people, I can tell. I don't know Kate all that much. I know you pretty well.
I'm just really mysterious.
You are. But you've got an aura of just decency and goodness about you. And good, and hella good studentness. I mean, my God. You going to grad school?
Planning on it.
Cool. What year are you in?
I'm a junior.
Oh, okay, so it's a ways off.
Yeah.
Next fall is when the fun starts.
Yeah. I'm excited.
Anybody, tell me a story. What is this?
Circle of radius 2.
Circle of radius 2. Yeah. It's just, what did you say? Bigger circle. Hell, all that's good shit. It multiplied the amplitude. The behavior is still cosine and sine in the x and y components, but the magnitude is increased by 2. So this is simply, now notice there's no specification on t. I haven't said what t can be, but I do know that if t, it's usually easier to draw the circle first, and then otherwise you get shit like this. Oh God, it's not getting better. But 2 minus 2 minus 2. Now what happens as t, if I let t just run from 0 to infinity, what's the story of the particle? Here's the particle at time 0, here's t equals 0. But if I say there's no restriction on time, let it roll forever forward, what's the movie?
Counterclockwise circle.
Oh, awesome. Counterclockwise rotation around the circle forevermore. So it's not just one trip around. This thing just keeps on rolling around. How could I restrict this? I want to talk about, this particle makes a full orbit. I don't want to talk about anymore. What's the t that I want to stop at?
2 pi.
2 pi. So now, yeah, exactly. So 2 pi gets me that full single revolution. And what's the difference between that and that? So this versus this. This, I feel like I'm an eye doctor right now. You want to see the first one again? This versus this.
T stops right before 2 pi.
Yeah, so if I do it like this, I don't repeat this first point. If I do add this, then I'm doubling up on that last point. May or may not matter. But it's just thinking this through, getting stronger. Okay, let's try another one. Same thing, I want to play with this. This thing is just so valuable to understand. You're going to be really happy that we did this. So let's go back. What about this one? I guess we're using freaking R of t for everything. Take a minute. What's that do? And if it helps, let's do the same domain on t. Yeah, let's do that. How does this cosine graph differ from this one, or this one? No phase shift, not a phase shift.
Is it like compressed?
Compressed, yeah. So its frequency is altered.
Yeah.
Is this one a tighter coil, or is this one?
The 2T is tighter.
Yeah, exactly. So think about it, you're taking t, and before you even find the cosine, you've moved it further along the normal route. You've doubled the route it would travel on. So if I were to sketch this out, it's literally 2 cosines where there used to just be 1 in that same span of time. So the higher this number gets, the higher the frequency gets. In fact, you could say that the frequency of cosine of AT is A over 2 pi. That's like hertz. That's literally cycles per second. Tell me if I'm wrong, physics folk, chemistry folk. I think I'm all right. Yeah, cycles per second. Yeah, sweet. Sounds good. Yeah, good. I learned that like a couple years back. I was like, I'm gonna just start tossing that out. Sounds like I know something. So this thing's spinning twice as fast. The sine is spinning twice as fast, or cycling twice as fast. So that's bad. It's not good. 2 pi, if you did that, I would say something about it. So there's pi. Same thing, right? It's just going twice as fast. So what does the picture look like, just in general? The trajectory as a whole, what does it look like? It's 2 loops around. What's the radius? Still 1, because the magnitude is 1, absolutely. So this is 2 trips around the unit circle. But the output trajectory looks exactly, think of 2 rotations here. Output looks the same. So there's some details hidden in these things that you have to really look at the equations for to get specific details out. Cool, good stuff. What else do I want to say here? Oh yeah, let's move to 3D. So let's play with this, because I was just having a lot of fun with this morning, thinking about it. Let's move to 3D. Arc t equals cos t sine t 2. Take a minute. In 3-dimensional space, what is the trajectory? So take the knowledge we have about the x and y stuff, and then come with on your page or in your head a picture. But God, for the love of God, don't use Desmos yet. Not that you even could.
No, it's possible.
It is possible you do have your laptop.
They banned my IP on Desmos.
I like that. I like that. I want to know what you were doing.
You don't want to know.
Oh God, okay. Just on the Regis campus though.
Yeah, they didn't care. Desmos cares though.
Yeah. I'm sure the Desmos IT department's way more together than the Regis IT department. Get a picture. Oh, dude, yeah, it's so good, so good. What kind of picture is that? Everything, you okay?
Yeah.
All right, good.
Kind of.
Okay, oh gosh, that's terrifying. Okay, you're messing with me. Good one, Camila. I was worried about it.
Okay. In terms of okay. How okay are the
You know the logical expression tautology? It sounds like a tautology to me.
Oh, wait, I'm good.
Yeah. Absolutely. No, it looks great.
This one's bad.
I get the point though.
There's a
This
point
looks
there.
good. This looks good.
I
So,
can't do it either.
if we were to look down the z-axis, if I was literally just looking, at the xy plane, so straight down the x-axis, z-axis, I would see ye old unit circle. Oh, wow. Oh my God, that. But from the side, we've incorporated, we've taken this, it's not just sitting down here, is it? It's raised up 2 units. So I've seen lots of neat ways to show this. Let's see if I can do a decent job of it. So that's that. It's always kind of fun to add hidden lines and stuff like that. So maybe, you know, that comes out and then that comes right through the center. These little moves kind of add dimensionality to the drawing. And that always, for me, was like a lot of fun. And you could just put 2 right there if you wanted. I also saw some beautiful cylindrical indicators like that. That looks pretty good. Anything you can do to help add that dimensional appearance to your picture. Okay, so that's cool. Let's do a different one. How about cos t sine t? Let's just be nice to ourselves and assume t is a non-negative number. It's a single line. There's no code. Like you're trying to hide it from me there. No, you just think he's silly. Yeah. Yeah. I want to see these drawings. That's a good place to start. Yeah, absolutely. Getting the framework set up, I like that. It'll probably help make it look like what it's supposed to look like. There you go. Yeah, that's the right idea. Make it dimensional. Yeah. Dollar sign. Just keep in mind the X and Y is spinning. The X and Y coordinates are constantly revolving.
I get it.
You get it?
No.
You don't get it?
No.
You were just saying you got it, I thought. Maybe not?
It was a joke.
Or were you saying get it?
No, I said I was gonna get it.
What kind of jokes are these?
I was lying. Yes. Apparently. I've accepted it, Dr. T, that's what it is.
Wow.
I've accepted it.
Oh, well, that's cool. That's always worth something for sure. Yeah. And so let's talk about, like, you know, go back to the days before you knew how to graph anything. You got some points, right? And maybe those days are not that far behind, or maybe they're still here. But always, you can just grab a few points. That really helps, and it kind of helps make your drawing nice. So 0 is, R of 0 is 0, excuse me, wow, 1, 0, 0. So I can come over here and get just, there's my first point. Now, one of the things to keep in mind is that that's the positive y-axis over there. And I can kind of grok that this, this xy stuff is going to move like this, because this is negative x over here, this is negative. So I picture the x and y coordinates continually rotating, but the z coordinate is increasing. That's it, yeah. So it's like a corkscrew, it's a spiral. So let's get some more points so that you can see that. Let's do r of pi over 2. R of pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1. And then this is just pi over 2. Pi over 2 is like approximately 1.65 or something like that. It's like half of 3, right? A little more than half of it. That might be a little much. That's 1.57. Is that right?
Yeah. You do.
Okay. Got it. Cool. So 1.6-ish. So when I'm at 0, 1, so here's t equals 0. Here's t equals, well, I'm going to raise it up. It's gone up. The z coordinate has increased. So right from here, this distance is going to be pi over 2 units high. And I'm at that. So So notice little things are giving me a dimensional feel here. And in the meantime, I know that XY did this, but the Z coordinate also increased at the same time. Does this look okay? Good? Yeah? And then this kind of just keeps on going. And then I'm gonna draw this, and then I'm gonna, that's starting to look really junky. It's pretty bargain-based drawing there. Let's fix it up a little bit. A few. Something like that. This is very non-uniform. Just imagine a perfect corkscrew going up. And then this goes on forever and ever. I'll put a little arrow at the top. What would happen if we let t be any real number? How would this change the picture? Go down, keep on moving down as well, and your z coordinate would become negative as well. All right, here's a new one for you. One more. Any questions on this?
Could you touch more on that real numbers business you just said?
Yes, absolutely. So the question was, if I didn't say t had to be non-negative, and I let t be a negative number, how would the picture change? And the z would start becoming negative, and so you would see this corkscrew going down below the plane as well.
Okay.
Does that make sense?
Yeah, it does, yeah.
Awesome, as long as you can picture that, you're getting it,
Yeah.
that's all. All right, here's a fun one. Let's take this one and tweak it. What if I put a T in front? And hell, I'll just make it 0, just to make it lives a little easier. What does this one look like? Think about how those numbers in front govern magnitude.
Like fire.
This is way more fun than I knew we were gonna have. This is great.
Yeah, so as T, yeah, okay. I agree. Neither do I.
Ain't got the feeling. Hope so. Looks perfect. Looks beautiful. This would
No,
be
okay.
no, but don't erase it. It's really good. If I had a T in the third component.
Oh, right.
You
so
see?
it's going up the
Yeah.
T.
So
Oh,
that was
okay.
like beautiful, and I'd actually pictured that. I was like thinking about that one, but I thought we'd chill out. So you like made a leap ahead. Good job.
So does it just?
It's super advanced. It's too advanced.
On a 2D plane?
Just well, it's in the X, so the z
It's in the
coordinates
XY
fixed.
plane.
Yes,
right?
yes, absolutely.
So it'd be like, I don't know. Where would I start?
And let me give you a tweak on this. Since if you get that, I'll come show what that's about. How do you draw that? So cool. Does it look really good?
Do that. That's pretty good.
Yeah, that's nice.
That's not
Dimensionality. Yeah. Think like at an angle, Alexander. It's gonna like be more ovalish.
Yeah.
Right.
Okay.
Yeah. So here's one for you. Let's go back to the plane.
Look at that.
What does this one look like? And let's just restrict ourselves. So this will kind of pull some things together. What's different about this? I switched the cosine and sine. So yeah, so get a picture. So you can't? What did you say?
You should do it from 0 to pi, because it's just gonna be a circle.
Yeah. Yeah, but it's a particle you're studying, so where does it start? It will be a circle, you're right.
It's just like. 0
It's
to pi
definitely a
makes
circle
sense.
again, definitely a unit circle, but there's something subtly different about it, that if we were particle physicists, we would care about it.
0 to pi just like makes it more obvious where you start. What do I know?
No, ours.
I don't know, show me.
Yeah.
That 0 and the 1.
Yeah, it's 0, 6, 0, 1. Yeah.
No, no.
Yeah, what you were saying there, Christian, that sounds.
Yeah.
Yeah, and maybe label where the particle's at times 0 times pi over 2 pi.
Is it like, do you think it's like,
Just getting a couple points gives you some of the important information you need.
No. Sine. You're right.
So I guess there's something else a little different about this, right? What direction is this spinning? This is moving clockwise, right? And how do I know that? Because I just grab these points. It's got that x squared plus y squared is 1, no matter what t is. But this one is not just starting at the top, it's rotating in the opposite direction, so clockwise. So here's t equals pi over 2. Here's t equals pi. Here's t equals 3 pi over 2. Yeah, sound good? Questions? Maybe grab a laptop or whatever you're gonna, or tablet or whatever. Anything you can pull up Desmos on. What's going on?
I forgot to charge my computer.
Oh no!
But it's okay.
There's a plug right behind you.
Yeah. I'm gonna see how far I can
Okay,
stretch
oh,
my
that's
battery
good.
life go before
Alright.
I need it.
Need a challenge today.
Of course.
Yeah.
Something to keep your blood pumping.
Oh yeah. Adrenaline.
Adrenaline rush. So go to desmos.com/3D. We're going to do a couple things here. First thing is, I'd like you to, I'm going to show you how to enter this, and I'll just do it on the board because you can't use this same notation. But I want to show you how to do a parametric thing, and then I want to show you how to do a parametric thing that depends on a parameter, because that's just freaking awesome. So, what am I thinking here? I am thinking, oh yeah, so cosine of 2t, comma, sine of 3t, comma, let's just put a 0 there, because we want the 3D thing up, but check this out. So to enter this, you want to, in the box, instead of saying whatever equals, just enter a left paren, cosine of 2t, sine of 3t, comma 0, right paren, and it'll know you mean parameter, and it probably a little box will appear underneath that says, you'll see it very subtly like t, and it'll, I think that happens.
Yeah.
Does that happen? Yeah. So maybe put in there 0 and 2 pi. I think you can even type pi.
Yeah.
Is that right? We'll find out. Or just 0 to 7. Be fine. Yeah, what else got here?
So you haven't used, it says that as a
But what if I made it like,
Yeah, I don't think that's going to give you anything because it doesn't know what x, y, and z are.
I wanna see like, I want to see like.
So if you want it to work, this is probably the stuff to enter. If you want to do whatever the heck is happening over there, I appreciate your adventuresome spirit. What does this look like?
Just like a fish. A fish.
Yeah, and then let's kind of rotate it. So like, what is it?
Just like that.
Cool.
It's like a spiral.
Yeah, what happens if we increase the pi? So let's increase the period here to let's see, maybe put like a 12 here or something. I think that, let the T run up to 12. There we go. Ah, yeah, that looks pretty good. That's cool. That's very cool.
Yeah.
So it is that fish shape, right? Sitting in the XY plane.
What's it?
You put your variable.
What do you mean?
This is not drawn with perspective or in the appropriate things.
Auto rotating.
Yeah, it was just so smooth. I don't know what's wrong with
Is that looking, we seeing cool stuff? Something moderately cool. You don't seem super impressed.
No.
Yeah.
Not yet, alright, well,
that. Maybe that's the problem.
Big crunch is bad, really.
let's change some things. Then let's make a parametric equation. So now we're gonna use R of t equals cosine of st. So now as you enter this, remember you're gonna have a left paren here. You're gonna enter cosine. The minute you say s, it's going to say, do you wanna add a slider? Yes, and the answer is yes, you do. Cosine of st, sine of t, let's just do sine of t here, and then let's put cosine of t as the third coordinate. And then you can change, oh yeah, that looks freaking awesome. And Camilla's having the kind of fun that I would hope you would have by moving that slider around and watching how the trajectory changes.
Well, I make this too powerful. That might help.
That's kind of cool.
Oh, that looks, yeah, there you go, cool. Look at that thing wiggling.
What is that?
Sphere.
That's a worm on a hook.
Yes,
Is everyone getting this to work for them? That's what I mostly want. I'm hoping
Yeah.
it's just it now.
Let's fix.
Let's fix.
Oh, I think it's because
Yeah.
I also have a slider for my TV.
You didn't,
Oh, yeah.
Oh, the pie, this is just two.
Yeah,
Just
yeah.
the cool stuff.
Would you set your,
Now you see the focus, yeah, yeah, so.
Yeah,
yeah.
Oh, yeah, there, like that.
You can even set it into motion. It's like a slow motion, like I see
Okay, can I set these parameters?
Spirals and then like.
oh, holy crap.
Yeah, that's the answer, that's the response.
10, no, 10.
Yeah, you can set that little coordinate axis into motion. If you just give it a little tug with some velocity, it'll rotate slowly or quickly.
Holy shit. This is pretty cool. Now I'm like surprised.
Oh, I see. Oh, wow. Oh my God, that's awesome. Oh, wow.
It's like glitched.
CPU's breaking out.
Oh, you're just having fun.
Make the, oh, the thing that's
Oh.
like.
See, this actually
Yeah.
is kind of see it more. It makes it like a ring.
Yeah.
You can get
Spirals.
those like frequencies of a
Pi.
sine.
Whoa.
Well, actually, I have no idea what.
So if you actually increase s to a really large number, if you allow the slider to go up really high like Talon did, you'll see some cool stuff.
Oh, I think 122, that's what it is.
Okay, so.
That's crazy.
What do we know about, so this is x, y, and z. What do we know about just the y and z coordinates? How do they relate?
At 4.5, it's just not activity.
That's crazy.
What's y squared plus z squared? It's 1, yeah. So in the YZ plane, and any slice that's parallel to the YZ plane, you're gonna see a circle. And so what you could see here is that in the YZ plane, the surface lives on a cylinder. So it's gonna live on a cylinder. That looks really bad. But then you see it kind of like doing this. I think that's what you're seeing, right, Talon? Kind of like, yeah, like, if you ever see a drum with like a bunch of strings on it holding the membranes together, something like that, yeah.
That's pretty cool.
It is good, it's good stuff. So I encourage you, now you have something to do for the weekend.
Yeah, this is plenty right.
Make up some weird shit, enter it parametrically. I think you could probably add a second parameter if you wanted. You might be able to put like a WT in here and
Oh, it
change.
does make it blank.
Yeah.
What's that?
Crazy. If you add a S to that second cosine, you get a plane.
Yeah.
It's the cosine, it looks.
Oh, what'd you do? Oh, yeah. Oh, yeah, yeah. Oh, that's groovy.
That's what I was thinking, cause it's
Yeah.
when you up and down, it's cosine.
Oh, no,
Yeah,
a
because this is
2.4.
So
So I feel like there's other stuff we can do, but we'll just do it on, Monday maybe?
Christian, you can spin it.
I owe you some time for
You can
sure,
work.
right?
Put the face.
Yeah, well,
that's
I
what
mean,
you can just spin.
Not you?
With the with
You
face
did, you worked,
gesture.
you worked hard.
Yeah,
Rose.
yeah.
Good job.
Yeah,
Oh,
You can just spin it.
you dropped my name in the video, that's all I know.
Did I?
That's how, yeah, you said, Alexander, you're watching this thing.
Oh, nice, yeah, I love, that's like, yeah, I like doing that. Let's call it a day. It's been a good week.
Actually, no, I'm not ready.
And yeah, I'll stay here with anybody who wants to do this. I have to go lead a meditation in the dorms in DeSmet. You're welcome to come. I guess, I don't know if you're allowed in the dorms if you
I
don't
don't
live
know
in the
if they are.
dorms.
That's true.
Doctor.
I'd rather not.
You're allowed, you just need like.
I don't really wanna go in
Like
Desmond.
talk to the
Yeah.
person at the front.
Oh.
strong desire to do that.
Yeah, I don't
Official
really need to
never
go
goes
back.
that way,
Yeah,
Ever again.
I don't remember the dorms ever being secure.
It was
when I was
fun.
in dorms.
Yeah.
For about a year, and then it wasn't.
This is like,
I said that, who knows Tommy, right?
Shut up.
Apparently Tommy was making a late night visit.